Hi everyone, Brea here from Actuarial, and today I'm going to go through a concept that really confuses people. I've worked with a lot of people in my study strategy program, and I know trying to figure out whether you should do dxdy or dydx when you're doing a double integration question can be really confusing. So I hope that this quick presentation, it might not actually be too quick, but anyway, I hope it will help you figure that out so that these questions will be really easy for you on exam day and you can quickly figure out whether you should do dxdy or dydx, and then you can move on, do your integration, get the correct answer, and go on to the next question. So I'm going to start off by going through one of the SOA sample problems. And I think this one in particular is really good. It's not too difficult, and it will allow me to show you how you should figure out whether to do dy dx or dx dy really easily. So the question is, an insurance policy is written to cover a loss x where x has density function f of x. The time in hours to process a claim of size x, where x is between 0 and 2, is uniformly distributed on the interval from x to 2x. Calculate the probability that a randomly chosen claim on this policy is processed in 3 hours or more. Okay, so like the question suggests, we're going to use the variable x to represent the loss, and I've decided to use the variable y to represent the time to process a claim of size x. So x is always going to be between 0 and 2, and y will always be between x and 2x. So the important thing to do first is to graph those lines. I've already done it here, but first we would graph the line y equals x, and then we would graph the line y equals 2x, because as the question says, those are our boundaries. We know that y has to be between x and 2x. We also know, we could also write that line y equals x as x equals y, and similarly we could also write the line y equals 2x as x equals 1/2 y. And sorry, I should have made that a bit more clear. It's x equals 1/2 y, not 1 divided by 2 times y. So we also know from the question that we want y to be greater than 3, because the question states, what is the probability that a randomly chosen claim, which we're representing as y, on this policy is processed in 3 hours or more? So we want to know the probability that y is greater than 3. We also know from the question, and this is where I was going, that x is between 0 and 2. So I've drawn the line x equals 2, and that just showed on the screen. So right now we have all of our boundaries graphed on this graph, and it's always really, really, really important to graph things like this because it can get confusing, and it's really easy to do a problem once you have a graph in front of you. So using all these boundaries, I've determined that we actually want to look for the probability of being in this blue triangle because it's meeting all our different requirements. It's above y equals 3, it's between x equals 0 and 2, and it means that y is less than 2x, but it's also above x. So using all those different boundaries, you can see that this blue triangle is the area that we're looking for. So the purpose of this video isn't really to go through and solve this whole question. What I really want to do is show you how you can figure out the boundaries that you should use when you're integrating. So, well, not only the boundaries, but how do you know whether you should do dx dy or dy dx too? So how do we know whether we should do dx dy or dy dx? I'm going to blow up the image that we were just looking at so that we can clearly see what's going on here. So first, when I'm trying to determine whether I should do dx dy or dy dx, what I do is I take a vertical line just like this one, and I put it into my triangle. And once it's in my triangle, I take note that the endpoints are on the line y equals 2x and y equals 3. So when I say endpoints, I just mean that the ends of this purple line. The top endpoint is on the line y equals 2x, the green one, and the bottom endpoint is on the line y equals 3, the dashed horizontal line. Now, I could also put a whole bunch of other lines in here. I've decided to put 2 other lines in, but it's just important to realize that the endpoints for those lines are on the same lines as the original one that I put in there. So for all 3 of these purple lines, the top endpoint is touching the line y equals 2x, and the bottom endpoint is touching the line y equals 3. If, for example, we had something like this, that would not be true, because some of the endpoints at the bottom are touching different lines than others. So, for example, the purple line on the left-hand side has a bottom endpoint of touching the line y equals 3. But if we look at the purple line on the right-hand side, you'll see that the endpoint for that line is touching the line y equals 2x minus 1. So if that's the case, we're going to have to do something different for our integration, and we're going to ignore that right now, but just know that our endpoints have to always be touching the same line. The top endpoint and the bottom endpoint have to be touching the same line. So in our example, that's exactly what's happening, and I know I'm being repetitive, but it's very important to understand that the top endpoints of these purple lines are all touching the line y equals 2x, the green diagonal line. And the bottom endpoints of those purple lines are all touching the line y equals 3. So when this is the case, that tells me that we should do dy dx. Okay, so next, once we know that we're going to do dy dx, that's when I start looking at the boundaries of the integration. So we know that we're going to integrate with respect to y first. It's the inner integration. So I'm going to first look for the endpoints for y. And I want to find those endpoints using exactly the same method that I was just talking about. For all these purple lines, the endpoints are y equals 2x and y equals 3. And so yeah, those will be our boundaries for our integration later. But first we're going to find the endpoints for our dx integration, our outer integration. In this particular problem, we have to figure out that exact intersection of where y equals 2x meets x equals 2. Because right at that point, that is our first boundary for x. So as you can see, since y equals 3, we know using the equation x equals 1/2 y, we know that x equals 1.5 at that exact point. We also know that x goes all the way over to the right-hand side to the line x equals 2. So our endpoints for x are x equals 1.5, and x equals 2. And I got those two numbers from the red circled values in the graph on the left-hand side of the screen. Okay, so I'm going to move all that information to the top. Now, we know that our endpoints for y are y equals 3 and y equals 2x, and we know that our endpoints for our boundaries for x are x equals 1/2 and x equals 2. So let's start setting up our integration. Our inner integration is going to be for y, like we already talked about. Y goes from 3 to y equals 2x. Those are going to be our region of integration for y. Similarly, we're going to do the exact same thing for x. X equals 1.5 to x equals 2. And then once we know that, it's really just a matter of doing the integration. We have f of xy, dy dx. So once you solve this, you will get the answer to the question. But what's interesting about this is that it's something you actually may have already realized. And that is that we can actually put those lines horizontally in this shape too. We don't necessarily have to go vertical. And what's cool is that if we put them horizontally, you'll see that the endpoints of all those purple lines, you'll see that the endpoints of all those purple lines have the exact same boundary. They all have the endpoint on the left-hand side touching y equals 2x, the green line, and on the right-hand side, they all have the endpoint x equals 2. So what that tells me is that we can do dx dy as well. So if you can draw horizontal lines with all of the endpoints touching the exact same lines, then that implies we can do dx dy. Now for this one, the endpoints, we're always going to want to get our endpoints in terms of the inner integration. And what I mean is before we did dy dx, so our endpoints were in terms, or our boundaries were in terms of y. But for this one, we want our boundaries to be in terms of x. So when we're solving for our endpoints for x boundaries, we're going to use the equation x equals 1/2 y rather than y equals 2x, which is what we used before. And also our other boundary for x, and this is easy to see, I should have displayed it a bit better in the slides, but the endpoints that we're talking about first are the ones on the left-hand side. So all those purple lines have the endpoint x equals 1/2 y. They are all on that green diagonal line. And for all those purple lines, the right-hand endpoint is always touching the x equals 2 line. So that's going to be our other endpoint, or boundary. Now we can also determine at the very top there, that is the point x equals 2, y equals 4. So for y, our boundaries are going to go from y equals 3 all the way up to y equals 4. Now, just like we did before, we'll start with our inner integration, which is for dx. So x goes from 1/2 y to x equals 2. And then our outer integration, y goes from 3 to y equals 4. And then we do f of xy, and dxdy. Now, if we did this integration, we would get the exact same answer as we got before when we did dy dx. It doesn't matter whether you do dx dy if you follow all these steps, because you'll get the exact same answer. So when you're solving a problem similar to this, you just want to make sure that all your endpoints are touching the same lines. And if you can find a way to do that within your region that you're trying to integrate over, then that's how you can determine whether you should do dx dy or dy dx. This situation is unique because you could do it either way, but sometimes you get a different situation and that's not always possible. So I just wanted to go back to this really quickly and explain how you would do something like this. So in this situation, when we had set up the vertical lines, the vertical purple lines on this one, we noticed that the endpoints at the bottom were not always touching the same lines. Some of the endpoints at the bottom were touching the line y equals 3, and others were touching the line y equals 2x minus 1. So when that happens, we cannot integrate this shape using dy dx. Also, if we put horizontal lines here, we'd have the same situation because some of the endpoints on the right-hand side would be touching the line y equals 2, and others would be touching the line y equals 2x minus 1. So in this kind of a situation, we would have to split the region into 3 separate pieces so that we could do the exact same thing that we already did, but we'd have to do it in 3 chunks. That's going to take a lot longer, and probably on the exam they wouldn't actually get you to split something up into 3 chunks. It's possible. Maybe they'll do a really easy integration and expect you to be able to know that, but usually these kind of problems would take longer. I do know for sure, though, that there are questions where you have to split up an area into 2 separate regions so that you can integrate over them. So I hope that helps you understand whether to do dy dx or dx dy. I just wanted to throw this out there. If you want more help understanding exam P concepts, I'd love to help you in the study strategy program. One of the biggest things I emphasize is that you need to understand the concepts on the exam in order to give yourself the best chance of passing. It is so hard to do these questions just kind of partially understanding things, because when you just partially understand, it takes too long to figure out what you're doing, and it just makes the whole process inefficient, because you could be studying way better, you could be getting more questions right, and you could be getting done your studying quicker. If you just understand what you're doing, it makes things so much easier. And obviously, where you're writing an exam, you want to make sure that you understand these concepts, because they are used. Exam P concepts are used on the exam, exam P concepts are used in real life. As an actuary, you're using probability concepts all the time, so they're important. So if you'd like help passing your exam P, I'd love to help you in the study strategy program. Not only will I answer all your questions, but I give you step-by-step guidance to give you the best chance of passing your exam. It doesn't matter if you have 3 months left, only 1 month left. I'll show you what you should do with your time so that you're spending it the most efficiently to give you the best chance of passing. If you have more than 14 weeks left in your study period, I have a $225 pass guarantee where I pay your next exam registration fee if you don't pass, which is pretty awesome. So to find out more about that and how I can help you pass your exam, click the link in the description below. And if you like this video, give it a thumbs up. I'll answer any of your questions in the comments, and I'll see you in the next video. Bye!